Abrasive machining and finishing operations. In the last class, we already discussed on this how to improve the surface finish compared to each machining operations. In this class, we are a little bit going forward with respect to this finishing operations. Abrasive machining, when you compare these three pictures, we can easily understand that the surface finish of each component is comparatively increased. With respect to this is increased. With respect to this is increased. Why do we need a smooth surface? The first point is reduction in friction. If we have a rough surface, friction will be very high. Next, reduction in wear, bushing and bearings. See, if there are some peak and valleys on the surface of it, that surfaces will be removed, which will result in the wear of the particular components. For example, you can say bushings and bearings. Next, appearance. Car body furnitures, we always expect the surface should be very smooth in case of these car bodies and furnitures. Clearance, it is discrete. For example, sharpness, cutting tools, we always need the cutting tools to be very sharp to get the smoother or proper cutting on the particular parts. How do we get a smooth surface? First one, remove material with the help of this abrasive machining. First we have to remove the material, whatever some extra materials are there, that we have to remove it. Second one, flatten the surface with the help of burnishing operation. Third one, fill in voids. Fill in voids means if there are some gaps or some dents, that has to be filled with the help of adding extra material like paint, finish, wax, etc. What are abrasives? Abrasives, a small hard non-metallic particles with sharp edges and irregular shapes. They are not regular in shapes. These parts means what are the abrasive stones which you use, they are not in regular shape. They are irregular shape but which has sharp edges. Can remove small amounts of material producing tiny chips. It will remove small chips. The material removal rate, it is very smaller in compared to the other machining process in this one. Abrasive process can produce fine surface finishes and accurate dimensional tolerance. Some cases what will happen, we don't need some dimensional accuracy. Instead of that, we need smoother surface finish. In such cases, this will be helpful process. What are the types of abrasives? Conventional abrasives, for example, with the help of aluminum oxide, silicon carbides, you can get conventional abrasives. Super abrasive, cubic boron nitride, diamond. Abrasives, these are harder than conventional tool materials. These are very much harder compared to the conventional tools. What are the factors which will affect this abrasiveness? First one is grain size. The grain size means it depends on the size of the grain particles which we use. Second one is grain shape. As we said, it should not be in a regular shape. It should have irregular shapes. Next, hardness of that abrasive stones which you use. Next, tendency to fracture, how much material it will cut. If you see this diagram, you can easily understand these abrasive stones, this abrasive process, it will not require much pressure. Very low pressure is enough for this one, and also a short strokes would be enough for this. Next, coming to the first topic, a lapping operation. What is the meaning of lapping operation? This is used to enhance surface finish and dimensional accuracy of flat or cylindrical surfaces. Tolerances are on the order of 0.000 mm, means approximately it is equal to the 0.4 microns. Surface finish can be as smooth as 0.2025 to 0.1 micrometers. This improves the fit surfaces. Means with the help of this one we can get a good surface finishes. Also we will get a closer fits also. Abrasive particles are embedded in the lap or carried in a slurry. Means these are sometimes we can embedded means if you see like emery papers, in that some abrasive small particles it is already embedded in the paper. Sometimes we will put it in a slurry also. Next, pressures range from 7 to 140 kilopascal depending on workpiece hardness. Whatever the pressure which we are, based on the hardness of the workpiece, we will fix these pressures. Lapping, just this is a schematic diagram which will explain the production of the lapping process. For this production of lapping flattened surface, how the flattened surface can get lapped. Here lapping on cylindrical surface. Some examples of this one, just if you go through this you can easily understand. There are two types of abrasion. One is 2 particle and 3 particle abrasions. 2 particles, in these 2 particles the grains are already embedded in the surface. In 3 particles the grains are freely moved between the surfaces. This is the schematic diagram which will explain how the abrasiveness takes place. Means how does it remove the material, how it is going to affect. If there are materials, if there is an extra material, that extra material will be removed with the help of lateral cracks will be introduced. If directly if it is touching the surface here, then there will be a surface damage resulting in radial cracks. Lapping finish, by comparison to the grinding, how lapping finish we can get, how much lapping finish we can get. Types of lapping: single-sided lapping machine, double-sided lapping machine, cylindrical lapping. There are 3 different types of lapping. Just an example of this lapping process. And these are the parts which we can get from the lapping process. The next part. But the surface finish will be very much improved with the help of this process. Other finished operations like polishing, electro-polishing. Polishing means produce a smooth reflective surface finish done with disc or beds with fine abrasive grains. Here also we use small abrasive grains. And electro-polishing, here will with the help of electrolyte we will remove the materials, peaks and raised areas faster than lower areas. This is also used for burring operations. Deburring. Deburring means whatever the sharp edges which we will get from the machining operations, we can easily remove with the help of this electro-polishing operations. Examples of this polished machine, how it can easily remove the surface of that machine. Examples of polished parts. You can see some coins or some disc drives, heads, how much we can material can be removed from the surface. Whatever the extra material it is not required, that also can be removed with the help of this. These are the results which we can get from the polishing operations. Deburring. What are burrs? Thin ridges that form on the workpiece edges during production can be detrimental to the part or its function. These burrs has to be removed after machining operation. Otherwise, what will happen? It may be injurious to, it may be not safer for the human body because it may cut the fingers. Traditionally removed manually can account for up to this. The cost required for this deburring, it is approximately 10% of the total cost of the part. Deburring process. These are all the process which with the help of this one: manual, mechanical by cutting, wire brushing, abrasive beds, ultrasonic machining, electro-polishing, electrochemical machining, magnetic abrasive machining. So many types are there. All these, please go through this once. Deburring process, as I explained, shard blasting. It is also another process where we can get different types of abrasive stones which will be put in that container, and the parts will be rotated inside that, which will remove the sharp edges. Yeah. These are also deburring processes. Finally, abrasive process offer a way to increase surface finish and dimensional accuracy. Deburring may be necessary for proper part fit and functions. Otherwise, what will happen? With the help of this deburring, first thing, it will get smoother surface finish. Second thing, it will remove the burrs. Third one, it will help for dimensional fitting. Thank you.